Okay, let's look at this integral. So it's the integral of secant of x over tangent squared of x. We are, let's look, where are we with this problem? So the options we have, power of tan equals 0. That's not us because the power of tangent is -2. Okay, what about the power of secant is even? Nope, that is not us because the power of secant is odd, it's 1. What about the power of tangent is odd? Nope. Our power of tangent is even. What about the power of secant is 0?
It's 10 o'clock.
And the power of tangent is even. That is certainly not us. So all of the little tricks that we have.
It's 22 hours.
Right? Power of tangent is 0. That's not us. Power of secant is even. That is not this case. Power of tangent is odd. Not this case. Power of secant is 0 and the power of tangent is even. Not this case. So what do? If all else fails, we just try to convert our secants and tangents into sines and cosines and see what we can do from there. So let's go ahead and do this. So if we have the integral, if you have the integral of secant x over tan squared x dx, we can rewrite this as 1 over cosine x, because that's the identity for secant of x. And tangent squared of x is going to turn into sine squared x over cosine squared x. And all of this is dx. Now to simplify this, to get a common denominator, no, we just need to simplify it. What I'm going to do is multiply the top and the bottom by cosine squared x, right? So that's going to cancel out. And then this numerator, cosine squared x. Now I should have just the integral of cosine x in the numerator and sine squared x in the denominator. Now, do we know what to do? I'll tell you what to do. Let's do a u substitution. Let u equal sine x, then du is cosine x dx. All right, so we'll have the integral of du over u squared. That's the same thing as the integral of u to the -2 du. To integrate this, we add 1 to the exponent and divide by our new exponent plus c. And remember, u is really sine, so this is -1 times 1 over sine of x plus c, which we can write as negative cosecant x plus c. Okay, so now probably the thing that is tricky about all of this is trying to figure out exactly how to solve each integral. And it may be the case that you try 2 or 3 different things. You want to have these ideas just kind of looming in your head. Okay, u substitution should always be a go-to. We know we've got these trig identities, so use the trig identities in addition to the fact that these derivatives of secant and tangent are related and the derivative of sine and cosine are related. Use these to your advantage to figure out how to integrate. So it doesn't really make sense to try to memorize each and every possibility. It's more you see the same techniques being used again and again, so you kind of see how to play. You get ideas about how to play with integrals and manipulate them and try to make them something that's easier to integrate, make them into something easier to integrate.